We can also study the formation of images by spherical mirrors. We can also study the formation of images by spherical mirrors using ray diagrams. Using ray diagrams, we can draw ray diagrams and study the nature of the images. For this purpose, we use two rays. We use two rays out of the following four. Among the following four, we use two rays for drawing the image. The four rays are: 1. The ray parallel to the principal axis. The ray incident parallel to the principal axis. Second one, the ray passing through the focus. The ray incident passing through the focus. The third one, the ray incident passing through the center of curvature. The center of curvature. The ray incident passing through the center of curvature. The fourth one, the ray incident at the pole oblique to the principal axis. Oblique to the principal axis. The ray incident at the pole of the mirror oblique to the principal axis. These are the four rays selected for drawing the ray diagrams. Among these four, we use any two of the four rays selected here. One is parallel ray, the other one is passing through the focus, the third one is passing through the center of curvature, the fourth one incident at the pole of the mirror. We have selected four rays for drawing ray diagrams. This is because we know we can easily identify the path followed by these rays after reflection. After reflection. For example, the ray which is incident parallel to the principal axis passes through the focus after reflection. After reflection, it passes through the focus. The ray incident through the focus, it travels parallel to the principal axis, after reflection. After reflection, the ray incident passing through the center of curvature, it retraces its path. It retraces its path. It will be reflected along the same line. The ray incident obliquely at the pole, it obeys the law of reflection. I is equal to R. I is equal to R. Hence, because we can easily locate the reflected rays, we select these four rays. These four rays are selected because we can easily identify the paths followed by them after reflection. In the first figure, we notice a ray incident passing parallel to the principal axis. At the point of incidence, it undergoes reflection such that I is equal to R. AC is normal. AC is normal. Hence, we can draw the reflected ray at the same angle of incidence, and this ray passes through the focus after reflection. This is in the case of a concave mirror. In the second figure, you notice the ray incident on a convex mirror. On a convex mirror, it also obeys the law of reflection. I is equal to R. Hence, it appears to be coming out from the focus after reflection. It appears to be coming out after reflection. Like this, we draw the ray diagrams when the ray is incident parallel to the principal axis. The ray passing through the focus. The ray passing through the focus. In the first case, you notice the ray incident passing through the focus and draw the normal at the point of incidence. Then draw the ray, reflected ray, such that I is equal to R. You notice that the reflected ray travels parallel to the principal axis. The reflected ray travels parallel to the principal axis. This is in the case of concave mirror. In the case of convex mirror, In the case of convex mirror, the ray which is incident on the convex mirror passing towards the focus, it will also undergo reflection such that I is equal to R, and after reflection it travels parallel to the principal axis. This reflection is indicated in the second figure. In the first figure, you notice the ray incident passing through the center of curvature, and the arrow mark towards the C indicates the incident ray direction, and the arrow mark towards the C indicates the direction of the reflected ray. Similarly, in the second case, in the case of convex mirror, the ray is incident passing towards the center of curvature, and that is indicated by the arrow mark towards the mirror, and the arrow mark away from the mirror indicates the direction of the reflected ray. In the first figure, you notice reflection by concave mirror by the ray incident at the pole of the mirror. Here you notice that I is angle of incidence, which is made by the incident ray with the principal axis, and R is the angle made by the reflected ray with the principal axis. Similarly, in the second case, in the second figure, you notice reflection by the convex mirror when the ray is incident at the pole of the mirror. We select a linear object. We represent it by a line. On this line, every point acts as a source of light. So we imagine that this line is composed of several points, and each point acts as an object, and from each of these point objects the rays will travel and the image of each point will be formed. Like this, we imagine the formation of the images. Generally, we consider the top point or the topmost point of the linear object, and from this point we draw two rays. We select two rays and we use these two rays for forming the image. And the image of that, so the image formed is the image of the point object, which is the tip of the linear object.